Hey everybody, welcome back to Blackboard Biology. Again, I'll probably get around to changing the name eventually because obviously we're doing much more than just biology now. Today we're going to get back to some ACT prep math, and specifically we're going to look at some factoring practice. Okay, and so again, if you're my Scott High students, this will follow along with your assignment that we did, that I gave you yesterday. All right, so what we're going to do is, again, we're jumping in with some practice here. We're assuming you already have a little bit of a basic understanding of how to do some factoring, and I'm just going to provide some assistance on these types of problems. So this first one says, if 3z squared plus 6z equals 24, what are the possible values of z? It wants to know what are the solutions to this quadratic equation. Well, the first thing that we're going to need to do is rearrange this quadratic equation. So I'm going to pull this 24 over to the other side. I'll subtract it from both sides of the equation. It will cancel over here. And I'll have 3z squared plus 6z minus 24 equals 0. Lovely quadratic equation there. Now, the first thing I'm going to notice is that all three of these terms here in this quadratic are actually divisible by 3, and so I'm going to factor out a 3 of all of these, and so I'll take out a 3. That's a little thicker than I want. There we go. A 3 out of all of these, which will leave me with z squared plus, my 2's and my z's look a little bit alike, z squared plus, this is z, 2z minus, not 24. 24 divided by 3 is 8. Okay, there we go. And so, again, equals 0. So now I'm going to factor this quadratic right here. All right, and so we're going to be splitting it apart into two factors. And so I need, again, this is a 2. I'm going to need two factors of -8 that add to positive 2. So I'm going to go with positive 4 and -2. 4 times -2 is -8. Positive 4 plus -2 is positive 2 for my B term there. Okay, so now that I have these two factors, I'll just set each one equal to 0 in order to get my possible solutions. Again, these are z's. Z plus 4 equals 0, so z can be -4, or z can be positive 2. All right, and that is going to end up being choice B. All right, so rolling right along to the next one. All the following monomials are factors of this particular expression except which one? Now, in order for a monomial, that means it's a one-term thing. In order for a monomial to be a factor of an expression, that means it must be a factor of every term in that polynomial expression. And so what I'm going to do is I'm just going to peek through and I'm just going to test each answer choice one by one until I find one that doesn't actually work with all of these. And very quickly, I say that I'm not even going to test all of them because this one jumps out at me right here. All right, and I'll explain why in just a moment. But that's actually going to end up being our answer. The first thing I notice here with f, x squared, z, well, they all have at least an x squared and a z in them. So it is a factor. 3 goes into 24, -6, and 12. It is a factor. 3x squared z, well, they both were factors of it, and so you put them together here. That's actually also a factor. But when we get to j, 4xz, now 4 goes into 24 just fine, and it goes into 12 just fine, but what about -6? 4 does not go into -6 evenly. It is not a factor, okay? So that is going to end up being our answer there. Again, down here, 6 goes into 24, -6, and 12, and xz, they all have at least an xz in them, so that is also a factor. So that one, don't make it more complicated than it needs to be. You don't actually need to factor this all the way out. Just test each answer choice. 3. What is the sum? Interesting little wrinkle there. Make sure you're paying attention to that. What is the sum of the two solutions of the equation? So again, first thing I'm going to do is I'm going to make sure it's set equal to 0, which it already is. Factor it and then solve for the solutions. Okay, so I'm going to have x squared minus 3x minus 18 equals 0. So I need two factors of negative 18 that add up to negative 3. Well, negative 6 and positive 3 will multiply to give me negative 18, and they will add to negative 3. All right, set each factor equal to 0. And I will have positive 6 and negative 3. Now, it actually asked me again, don't forget, for the sum of these. So what is 6 plus negative 3? Well, 6 minus 3 is positive 3. And so the sum is positive 3, and the answer will be E. Okay, so we'll roll right along. Keep going. So again, if you're one of my Scott High students, we're now moving into exercise 2 from yesterday. And it says, which of the following expressions is a factor of the polynomial x squared minus 2x minus 24? Well, we could, do some factor multiplication here, but the best thing would just be to factor the quadratic very quickly ourselves. X squared minus 2x minus 24. Again, I need two factors of negative 24 that add to negative 2. So I'm going to go with negative 6 and positive 4, because negative 6 times positive 4 is negative 24, but when you add them, you get negative 2. And so it just wants to know which of the following expressions is a factor. So I'm going to look and see, is there x minus 6 or is there x plus 4? The only one that is up here as an answer choice is x minus 6. Okay, nice and easy. Number 2, which of the following is a solution to the equation x squared minus 16x equals 0? We have a couple different options, and I'll show you both ways. My first thing, especially if we're on the ACT and we're under some time constraints, my first option, what I would do is I am going to start plugging in answer choices. Okay, it just depends if you're in a rush, if maybe you're not as comfortable with factoring, just plug in answer choices. And so let's try it. What about 32 squared minus 16 times 32? So I plugged in 32 everywhere there was an x in the equation. Okay, so I'm not actually going to have to even evaluate this. I can just tell by looking at it that, okay, 32 squared is 32 times 32, and that is not going to be equivalent to 16 times 32. So these are not going to work out to be 0. That's not a solution. Okay, so what I'm noticing here, because of that 16 times x, whatever I put in for x is going to have to be 16, right? Because only 16 squared, let me switch colors here. Only 16 squared will be equivalent to 16 times 16. Okay, so moving on to the next one. If x plus 2 is a factor of 3x squared minus 6x plus k, what is the value of the integer k? Okay, well, if we want to solve for k, we need to know the other things. We can't have two variables because we only have one expression here. So what we're going to need to do is take this factor that they've already given us and just set it equal to 0, and we'll have a solution. If we set the entire equation equal to 0, we have a solution there. So negative 2. So I'm going to plug in negative 2 everywhere there's an x in this quadratic, plus k, and again I have to set it equal to 0 because I set the factor equal to 0. All right, so negative 2 squared is positive 4. 4 times 3 is 12. Negative 6 times negative 2 is positive 12. Okay, and so 12 plus 12 is 24, so I'll have 24 plus k equals 0. And if I just keep working there, subtract the 24 from both sides, I'll end up with negative 24 for k, which is choice A. Moving on to here, this one actually asks us to explain something. Explain why 6x squared z is not a factor of the expression given. So 6x squared z is a monomial. And remember, in order for a monomial to be a factor of an expression, it must be a factor of each term in the expression. Well, I look right here and I see 6x squared. Our middle term here does not have an x squared. It only has an x. Therefore, 6x squared z cannot be a factor of it. So it's not a factor because it's not a factor of the middle term. All right, and so rolling right on. Number 2 here, again, if you're my students, we were on exercise 3. A student believes that some of the solutions of an equation is the sum of the equation x squared plus 4x plus 4 equals 0 is 4 because the factors of the equation are x plus 2, and so 2 plus 2 equals 4. Using the same approach, a student factors the equation x squared minus 4x minus 12 and finds the sum of the solutions to be negative 4. Is the student correct? If not, identify the mistake in the student's procedure. And so what we've got here is we've got a student who is solving it, and they just so happen to be working with they factored it correctly, and they just so happen to be working with one where it kind of works out this way. But what we end up with is they factored correctly on the first one, okay, but the sum of the solutions, well, the solutions are not 2 and 2. If we get factors x plus 2, okay, we have to set them equal to 0 and solve for them, so we end up with solutions that are negative 2 and negative 2. Now, when we add those, we end up with negative 4, not positive 4. So the student is actually incorrect. And so what he or she used the same approach, all right, and they factored the equation x squared minus 4x minus 12 and finds that the sum of the solutions are negative 4. Okay, well, if we were to factor that out, our factors would end up being x minus 6 and x plus 2. So what the student has done is they've just taken negative 6 and 2 and added them together, but you have to solve first. Again, we have set these equal to 0, and so we have to solve first. So we would actually end up with 6 minus 2, which would be positive 4. So in this case, the student is incorrect. They factored correctly, but they didn't actually solve and get solutions. They stopped at the factors. Okay, so again, my students, we're on exercise 4 now. Jim is asked to find a factor of the polynomial 3x squared plus 6x minus 24. He has found 3 to be a factor. Is Jim correct? If no, why not? If yes, what are the other remaining factors of the polynomials? Okay, so Jim is correct because each term is divisible by 3. Okay, and so you can actually factor out that 3, and you would be left with x squared plus, it's not 6, excuse me, x squared plus 2x minus 8. Okay. And he said, the question asks, if no, why not? If yes, what are the other remaining factors of the polynomial? So he is correct, so let's find the other remaining factors. Okay, so we're going to factor this down further. We'll have x x. And now we need two factors of -8 that add to be +2. Well, that's going to be +4 and -2. So there are the remaining factors. So we're actually done right there at that point. We could go further and find the solutions by setting it equal to 0, but that's not what it asks us to do. So rolling on to our very last problem. It says Nikki is trying to find the value of k in the equation, this is very similar to a question we had earlier. 4x squared plus 6x plus k equals 0, given one of the factors of the equation is 2x plus 7. Explain how Nikki should proceed to find the value of k. Well, if we're explaining this, we have a factor already. Let's solve for the solution of that factor by setting it equal to 0. All right, so we'll subtract 7 from both sides. We'll end up with 2x equals -7. Divided by 2. So we know that one solution for this equation is -7/2. Well, I'm going to take that solution, I'm going to plug it back into the original equation. So I'll have 4, and where there's an x, I'm going to put -7/2 squared plus 6 times -7/2 plus k equals 0. Now k is the only unknown variable in this equation. So over here, let's evaluate this. 2 squared is going to be 4 on the bottom, and 4 divided by 4 cancels out. So this is actually going to be -7 squared, which is 49. Over here we have 6 divided by 2 is going to be 3. 3 times -7 is -21. 49 minus 21 will be 28. And so when we subtract, k is going to be -28. All right, and just like that, we're done. So I hope this video has been helpful to you in learning a little bit more about how to do factoring, especially factoring quadratics. And as always, I want to encourage you, you can like the videos, comment, subscribe, ask for new topics, new videos. And as always, thanks for watching.